Alright students, this exam review is optional and it follows the PowerPoint that I have put into Canvas, so please feel free to move back and forth throughout this lesson as you need to. Here's our first problem. We are given the cosine of theta is -5/8 and theta is in quadrant 3. We need to find all the rest of the trig ratios. So what I do is I start out by writing all my ratios. Now I know that secant is the reciprocal of cosecant, so I can pretty easily write that in. But for the rest, I need to remember all those x, y, and r values that we had. So I use the distance formula. And for cosine, this is x over r, so r is 8. So y is equal to plus or minus square root of 39. So now I can go back in and fill in some of these others. Sine, because we are in quadrant 3, sine is negative. So that's negative square root of 39 over 8. That means that cosecant is negative 8 root 39 over 39. Remember, I took the reciprocal and then I rationalized. Tangent is y over x. So tangent, being in quadrant 3, is positive. So that gives us 5 root 39 over 39. And cotangent is simply its reciprocal, positive square root of 39 over 5. This lesson is over solving triangles, right triangles using SOHCAHTOA, also including angles of elevation and depression. We see that most in word problems. So we have a tower. And from a point that's 93.2 feet away, we have an angle of elevation. That's 38 degrees, 20 minutes. And we have to find h. This is basic right triangle. We have opposite and adjacent, which means that we're using tangent. When I rearrange, that means I multiply both sides by 93.2. And then I simply put this into my calculator, but I have to make sure that I'm in degree mode to do that. And when I do, I get that the height of this is 73.693 feet. And with this being a word problem, I would probably need to write a sentence as well. With arc length and sector area, the most important thing to remember is that your angle must be in radians no matter what. And of course, it's never given to you in radians. So if we're lying on the equator, that means we're on the Earth's surface like this. I have one city that's at 35 degrees west, and another city that's at 72 degrees east. And remember, that's of the prime meridian, so we actually have to add those two values together in order to find out what the angle is. but that is in degrees, so I need it in radians. So, in order to find this distance, I'm looking for an arc length. The radius here is 6,400, because remember that is the radius of the Earth approximately. I've given you an answer in terms of pi, and I've also multiplied it through. Again, with this being a word problem, you probably need to write a sentence. The biggest struggle with linear and angular speed is again remembering that you need to be in radians per unit of time. Here I'm looking for linear speed, which is v, and the formula is v equals r omega. R is pretty simple because it's 7. The omega is the part that's hard. It says that it's rotating 90 times per second. So that's 90 revolutions in 1 second. And 1 revolution is 2 pi radians. I'm not told that I need this to be in any particular unit of speed, so this will be fine. So now that I have omega in terms of radians per second, I can multiply this out. And again, I've kept it in terms of pi, and also I've multiplied it through. This next problem is one of the hardest things that you guys do. So for starters, I'm going to call your attention to this. We need this number that's attached to x to be pulled out. So that's where we start. We then get x minus 1 in parentheses. Now we can list out all of our information. Remember, the period is 2 pi over b, and b in this case is pi, which means the period of this is 2. The vertical shift is up 1, and the phase shift is 1 to the right because of this minus 1 there. I am running out of room a little bit, so I'll do the rest on the negative side of the graph. From here, remember, I want to see your 5 numbers. So the period starts at 0 and ends at 2. Halfway in between there is 1. Halfway from 0 to 1 is a half. And halfway from 1 to 2 is 3/4. Oops, that is 3 halves. Then, because it's a cosine function, I know that cosine starts at its maximum or minimum, so I put in 1, 0, -1, 0, 1. I multiply every value by my amplitude. Then I add or subtract the vertical shift. That's a plus 1. So every number gets added 1. 1 minus a half is positive a half. 0 plus 1 is 1. 1 half plus 1 is 3 halves. 0 plus 1 is 1. And then again, 1 minus a half is positive a half. So from here, I'll actually plot these values. So I'll make this 1, 2, 3, 4. So I'm at 0, and we'll call this one 1 and 2. So at 0, my y is a half. At 1 half, y is at 1. At 1, y is 3 halves. At 3 halves, y is at 1. And then finally at 2, y is at 1 half. So there is one period of this graph. I can repeat that. And I could repeat it in the negative direction as well if I didn't have all this stuff written here. Now, this is not my graph, because remember that there's a phase shift of 1 unit to the right. So every one of these needs to move over 1 full unit. And then I can even backtrack this if I need to, because I know now that there's one here and one here. Now this red graph is my actual function. Remember, with the other 4 graphs, really, you need to just recognize them. So I'll show you once again how to do that. For tangent, what you need to pay attention to is that this y-intercept exists, as in this graph actually crosses the y-axis. If you look at cotangent, there's an asymptote on the y-axis. Tangent crosses, cotangent has an asymptote. For the others, what you're going to do is connect these points here to see if you have a minimum or a maximum at 0. So this graph that I just drew, that's cosine, which means that the blue one is secant. This pink one here, that's sine, which means that the blue one is cosecant. Now, a lot of the trig and inverse trig is going to require you to use unit circle. You're going to know if you need the unit circle if you end up with something that looks like this versus this. For this one, you're going to need calculator. For that one, it's unit circle. So if I'm looking for the arctangent, square root of 3 over 3, I need to remember that arctangent will exist only in these quadrants. And I need y over x to equal square root of 3 over 3. So I start looking at these values. Well, I've got a square root of 3 here, and I've got a square root of 3 here, and I've got one here, and I've got one here. Now, what I have to pay attention to is this one will be negative, because there's negative over positive. Same with this, negative over positive. So it can't be either one of those. It'll have to either be pi over 6 or pi over 3. So when I start dividing, 1/2 divided by square root of 3 over 2. And you copy that flop. You get 1 over square root of 3. And when you rationalize, you get square root of 3 over 3. So in this case, y is equal to pi over 6. Now, how did I know to use pi over 6 as opposed to 30? Well, because of this y. If it's y, you use radians. If it's theta, you use degrees. For the next one, the inverse cosecant, we're going to have to put this into our calculator because this is not anywhere on the unit circle. But of course, there is no cosecant on the calculator, so what you have to input is the inverse sine of 1 over this number that you've got. And when you do that, the answer you get is that theta is about 7.674 degrees. Next is the ambiguous case of a triangle. Now, I'm not going to ever tell you, hey, by the way, this triangle is ambiguous case. You have to figure it out. So the way you do that is you draw your triangle and you start labeling. Now remember that side A is opposite angle A, so this is side A. And then side B is opposite of angle B, so that right there is side B. And then what I do is I start looking at things in order. If it's side, angle, side, it means that the two sides create the angle that you're given. If it's angle, side, angle, then the two angles create the side in between. This is angle, side, side. That means it's got to be ambiguous case. So to start, we need to use the law of sines to find angle B. And with this, I simply cross multiply. $86.4 times the sine of 61.7 divided by 78.9. And I get, for angle B, and I call it B sub 1 because I know it's ambiguous case now, 74.617. I then have to calculate a B sub 2. Now remember, B sub 2 is just the supplement, so 180 minus B sub 1, and I get 105.383. Please notice that I did not write any of these values here. Once I've gotten this, I can get angle C. For C sub 1, I'll take 180 minus A minus B sub 1, and that gives me 43.683. To find C sub 2, here many of you want to find the supplement. This is not correct. You start over again, 180 minus angle A minus B sub 2. And this is 12.917. Now you have to find the third side. To do that, you're going to redo law of sines. But you'll use angle C. And again, you cross multiply. 78.9 times the sine of 43.683 divided by the sine of 61.7, and that's lowercase c sub 1, 61.89, and then you repeat that process for lowercase c sub 2. And that gives us 20.031. Too many ones on that. Don't forget your degree symbol. And don't forget that you always have to check for that second triangle. There is one typo on this one, and it is here. This is lowercase a because it's a side length, and we're supposed to determine the area of a triangle. Well, we have the area formula. It's 1/2 AB sine of C. So in this case, that's make sure that your calculator is in degrees, and you get 20.268 square feet. Alright, the last problem is a law of cosines problem, although, again, I won't have told you it was law of cosines. You'll have to draw the picture to figure it out. But we have boats leaving a dock. They each travel in a straight line. The angle between them is 54 degrees, 10 minutes. And we get told that one boat is going 36.2 kilometers per hour, and the other is at 45.6 kilometers per hour. And they also tell you, by the way, we're going 3 hours. So you have to multiply each one of those by 3 to get your distance. That means that the first boat has traveled 108.6, and the second boat has traveled 136.8, and we need to know the distance between them. Well, that's a side angle side. That means we get to use law of cosines. So that's a squared plus b squared minus 2ab times the cosine of c. I would put this whole thing into my calculator, and when I do, the number that comes out is c squared. So I have to take the square root.